In these problems, we are evaluating exponential functions with base e. So this expression e, that's not a variable, that's a specific number. It's just one of those numbers like pi that never ends, the decimal never ends, so it's inconvenient to write down. So we use e, and often on calculators, there'll be an e button that you'll have to use for these. There's E is one of these functions that's special. E to the x in calculus, its value, the value of the function, is the same as the value of its derivative at every point along the graph, which is strange and interesting. And it also happens to give E a really useful role in calculating the values of exponential growth and exponential decay, continuously compounding interest, and things like that. So you'll see it pop up in those contexts. There's nothing too hard about this type of problem. We're really just going to be typing this into a calculator and hitting equals, but you need to know what to put in for t, and you have to type it in correctly, but I don't think this should be too tough for you. Let's do one, and I'll read this first. It says, suppose that the velocity, v of t, in meters per second of a skydiver falling near the Earth's surface is given by the following function, where time t is measured in seconds. Okay, so v of t tells us how fast the skydiver is falling. We just put in, for the variable t, we put in however many seconds they have been following. And we want to find the velocity after 1 second and after 5 seconds. Okay, that's not going to be too hard. Let's just start typing in the function as it is listed there. So we have a 53, and then we've got parentheses, and then we've got 1 minus. Now, where it says e to the negative 0.21, we start with e to the x there. And then we're going to put in the power. In this first one, t is 1, so negative 0.21 times 1 is just negative 0.21. So I can type in negative 0.21. Okay, and then I'm going to hit the forward arrow to get the parentheses back down on the right level. That's the tricky bit there. And I think we've got all of that set up correctly. So I'm just going to hit equals and see what we get. And we've got a velocity of a little over 10 seconds. It says round your answers to the nearest whole number. So this one clearly would round to 10. Okay, we're halfway there on this one. Let's try the second part. For this one, we want to find the velocity after 5 seconds. This should be interesting. How much faster do you think this person will be going? They're at 10 meters per second now. How much faster after 5 seconds? Well, let's see. 53 parentheses, and then we've got 1 minus, and then we've got our e to the x. And now I'm going to multiply this negative 0.21 times 5. So we'll put in negative 0.21 times 5. And then I think I can get away without the other parentheses. Let's just try and see. And we'll hit equals there. And we get 34.45. That would round to 34. So if we did that correctly, it's quite a bit faster, almost 3 times as, or more than 3 times as fast after 5 seconds than after 1 second. Well, let's see if we got this right. There we go. So I'm not going to do another one on this one because really it's just plugging stuff into the calculator. So that's a little bit of work with evaluating some exponential functions.